Hello everyone, welcome to our YouTube channel. So I am Jerry. Today we are going to learn the Fourier series for periodic signals. So today we are focused on the trigonometric Fourier series. And then we will learn how to apply the Fourier series to solve problems. So before that, let us recap that what is the periodic function? A function f of t is said to be periodic if f of t is equals to f of t plus capital T, where the capital T is represent period. The period t is equals to 1 over f. The f is the frequency. So these are the example of the periodic functions. We have sine wave, square wave, triangular wave, and the sawtooth wave. Then, what is the Fourier series? Fourier series is the representation of a periodic signal in the frequency domain by its frequency components. So these are the Fourier coefficients that we need to find. Then this is the equation for the trigonometric Fourier series. So this is the final goal that we need to achieve for the question. Then inside the question, we have three Fourier coefficients that we need to find for solve the trigonometric Fourier series. We have A0, AN, and BN. So for these three Fourier coefficients, the formula will be provided.
Thank you, Jiwei. My name is Dan Serong. So we will continue analyze our questions. So the question we choose is the question 3 from section B. From the requirement, we saw that the requirement said that we need to write the expression for the trigonometric Fourier series that of the graph. Though the graph is the seesaw wave graph. So we need to express our trigonometric Fourier series with the equation ft equals to a0 plus summation an times cos n omega t plus bn times sin n omega t. So we need to analyze our Fourier coefficient with the equation that given from the appendix A. So we also continue analyze our seesaw wave graph. We saw that the graph is even symmetrical wave because ft is equal to f times f with negative t. So I will pass to Daiji Hao to solve the questions.
Okay, thank you, Serong. Now I will start to solve these questions. So the graph of the questions is given like that. So it is a even symmetrical functions. Therefore, we can conclude that the value of the bn is equal to 0. So we only need to find the value of the a0 and the an only. So from the graph given, we can see that the period of one graph is equals to -2 to 0 and 0 to 2, which means that the period of the graph is equals to 4. So to find the value of the omega, we using the equations 2 pi over t, and we find that the value of the omega is pi over 2. So from the equations of one period, by using the equations to find the value, we can find that the equations when the functions is calculated from -2 to 0, the value is -t plus 2. And for the range of 0 to 2, the functions is t plus 2.
So thank you everyone. And I'm Kenan. Now we'll proceed to finding A0 and AN. To find A0, we can actually use the formula that has been written on the slides, which is 1 over t integrate ft dt. Then we can substitute the relevant value inside the formula. And in this case, since the function is even function, then we can times 2 to it and reduce the range from 2 to -2 to 2 to 0 and proceed with the relevant integrations. Then we can get A0 equal to 1. To find AN, it's actually the same process with finding A0, just by using the formula written at the slides and then substitute the relevant value and times 2 since it is an even function. Then proceed with relevant integrations. Then eventually we'll get something like 4 over n power of 2 pi power of 2 times 1 minus -1 power of n. When n equal to odd number or odd value, then A0 will be equal to 8 over n power of 2 pi power of 2. And when n equal to even number, then an will be 0. After we getting the value of an, then we can actually substitute the an into the formula. And then we will get something like 1 plus summation of 8 over 2n minus 1 power of 2 times pi power of 2. And then cosine n pi t over 2. And then we can expand the summations into the form that shown in the slides. And that's all from us. Thank you.